in this kind of covers. Advantages of compliancy in ATs and GTs, that is guide tower and articulated tower. 1. Compliancy avoids concentration of high moments at the bottom. That is one major advantage we have. Therefore, high stress concentration are shifted from the bottom. Maybe in ATs it is shifted to the central tower. In GTs it is shifted to again the tower at 1/3 height. The third issue is the buoyancy chamber. In particular, in articulated towers ensures additional capacity of recentering. So, by compliancy, towers regain original position by displacements. In fact, I should say by undergoing large displacement. So, it is not a strength based resistance, but a displacement based resistance, what we call as compliancy. In addition, compliancy causes change in dynamic water plane area. So, therefore, these towers again have periods, natural periods varying from about 30 to 45 seconds in compliant degrees, especially the compliant degree of freedom for an AT is rotation at the base. In addition, as we just now saw, ATs have deliberated a single point failure. Can you guess where the failure would happen? Yeah, it will happen at the universal joint. So, universal joints are vulnerable to fatigue failure. Some designs of AT also have periods extending till 45 to 75 seconds as well. So, as a result, these structures have low dynamic amplification under waves. They also have lesser weight. So, installation is simple. The next variety what we can have in compliant structures is tension leg platform, TLP. TLP is a design where the weight is much lower than the buoyancy, or buoyancy exceeds the weight by design. Now, weight is acting downward, buoyancy will act upward, and buoyancy exceeds the weight. The difference between the buoyancy and weight is to be compromised by the axial pull or axial force in tethers. They are also called as tendons. So, the figure shows a typical tension leg platform whose top side is similar to any drilling or production platform. So, now these are the legs which are called otherwise tendons or tethers. They will be under axial tension. So, tethers otherwise called as tendons will be subjected to high axial tension. They are called initial pretension, indicated as T0. So, now W will act downward, FB will act upward, T0 will act downward. So, W plus T0 will be FB. That is the equation of static equilibrium of tension leg platforms, where T0 is the initial pretension offered. So, it is very simple. The system has excessive buoyancy, it will be pushed up. To hold it down, tethers will pull them down. So, all legs will be always in tension. That is why these platforms are called tension leg platforms. That is the reason why they are called tension leg platforms. Very interestingly, the concept of TLP can be also read at different papers 2007 A and B by Zeng et al. And other literature which he referred in the NPTEL website. Now, TLPs have uniqueness in design. There are two sets of frequencies or periods which are connected in TLP. Therefore, TLPs are hybrid systems, which I explained you already. So, surge, sway and yaw, which are flexible degrees, will have periods varying from 70 to 125 seconds. Whereas, heave, roll and pitch will have periods. They are stiff degrees, will have periods 2 to 5 seconds. So, the waves which will act this platform will be in between, so which will cause no resonance on the platform at all. So, I should say TLPs are flexible in horizontal plane and stiff in vertical plane, because surge, sway or displacements along x and y, which is horizontal plane, and yaw is rotation about z axis, which is also will happen on the horizontal plane. Similarly, heave is displacement along vertical plane, that is z axis, and roll and pitch are rotations about x and y axis, which will also happen about the vertical plane. So, for low periods they are stiff, therefore it is stiff in vertical plane. For larger periods they are flexible, therefore they are flexible in horizontal plane, and put together this is called a hybrid design concept in offshore platforms. So, interestingly, when a TLP is subjected to a wave action, TLPs will undergo displacements. Since tethers are inextensible, this displacement along x is called as offset. This displacement along heave is called set down. So, one can now notice that offset which happens along x axis and set down which happens along z axis are strongly coupled. What do you mean by coupling? When you give a x displacement, displacement along z automatically happens. Any displacement along z will change the buoyancy, will change T0, and therefore, the problem is dynamic in nature. That is why this T0 is otherwise called dynamic tension variation. So, we have advantages of alleviating the environmental loads by this kind of structural action. So, one can very clearly understand here that compliant structures resist loads by displacement, or you can say rotation, does not matter, in general by a compliancy in nature. This compliancy offers many advantages, but in case of ATs and GTs there are towers we need to extend for the entire water depth. Therefore, they are limited only up to a depth of 600 meters, whereas tension leg platforms has no such tower, they have only tethers. Therefore, they are insensitive in terms of cost with respect to increase in water depth. So, therefore, TLPs are preferred for deep and ultra deep waters. Further, we also saw when TLP is subjected to a lateral push, the change in tension, the horizontal component will offer resistance to the load, the vertical component will add stability. So, T0 horizontal component will resist the load, whereas vertical component will add weight which improves its stability. So, the TLPs has good recentering capability, restoration concept, simple in design, insensitive in cost with respect to water depth, and simple advantage. So, this is what we call as TLP mechanics. So, in the next lecture we will also see some more offshore platforms which are meant for ultra deep waters and new generation platforms which are recently conceived. We will talk about their structural action very quickly and understand how these kinds of platforms are useful for deep and ultra deep water oil exploration and production. Thank you very much.